Reducing regulatory burden through automated compliance checking talk. And we've got Nick Van Best and Regis Reverett to present today. So I'll hand over to Nick, and Nick, I'll give you guys a warning in about 13 minutes or so that we allow 6 or 7 minutes for Q&A.
Yeah, sounds good. Thanks a lot for the introduction. So in this particular talk, we would like to explain how we would automate compliance checking on the farm, taking into account welfare guidelines, standards, etc. So there's a number of aspects here in this particular topic that would be very important in terms of technology. So that's why I'm co-presenting with my colleague, Regis Reverett. So to set the scene a bit, you've probably seen this slide before in the presentation. So in the entire supply chain, every single aspect there is subject to guidelines, regulations, etc. So what we are specifically trying to do in this part of the project is to connect the welfare guidelines and meat standards on one hand with the actual data and information that we can gather from the animals on the farm, from the data being provided by the farmer, and partially also the data that we can collect when the animal is actually in transport towards the processing facility. So when we compare this to the actual architecture that we have, we would be particularly focusing on these particular topics here. So the onboard classification and checking of rules and guidelines on the actual animal itself, that will be covered by Regis, and the automated certification and animal transport compliance, that will be part that will be in terms of technology being covered by me during this presentation. So first we need to start with a digitalization of the welfare guidelines and standards. So if you've got the actual standards in plain English, you cannot really use that in a software algorithm or a machine and just expect that machine to interpret that. So there needs to be a formalization and a digitalization of those rules such that the machine can actually reason over that. So we have a specific way of structuring that particular data in such a way that it is not only machine interpretable, but at the same time also understandable still by human beings. So that gives a great opportunity to have a one-on-one match between the actual guidelines in plain English and the sort of digitized, more formalized version as we like to use it. So in this particular project, we had a number of different categories. So we have animal handling, water access, feeding access, and parts of the animal transport that we took into account. And we took a sample of each of these categories to make sure we've got a reasonably broad overview of different aspects along the entire process, so that we would be, absolutely sure that our technology could actually cover these kind of rules. Now, a lot of these rules are formulated with human interpretation in mind. So that means that they're not exactly specific or measurable in all cases. So to give you an example of that, consider, for example, this rule: cattle should have reasonable access to water at least daily. Now, for probably a farmer, this would be easy to determine. For me, as a computer scientist, it was already a bit harder, because what does reasonable actually mean? This is very hard to quantify. I can't actually get a sensor that tells me, at this point, the cow has reasonable access to water. So I can measure a lot of things, but the word reasonable isn't one of them. So if we would like to digitize rules like this, then we need a bit of pre-processing. Because if you would say, look, we've got an obligation that says we need to have cow access water daily, we need to measure that, and we can identify whether that's true or false, and as a result we can prove whether we are compliant or not. This obligation by itself is not really that meaningful, because again, cow access water daily is something we cannot really measure. So as a result, in a number of cases, we actually do need a few auxiliary rules. So we are able to identify whether a cow has been drinking, we are able to identify whether a cow has proximity to a water trough, and we can identify how much rain there has been. So whether the rain, for example, has surpassed a certain threshold in the past couple of days, and we know that that the cow doesn't need that much water for the past day. So using these auxiliary rules in certain cases, we would be allowed to support that particular obligation and sort of quantify it and more specifically formulate what reasonable actually means. So after this pre-processing and formulating those rules, we are able to do what we call compliance checking. So on one hand, we have to digitize rules, and on the other hand, we have data that we can obtain from the animals through the ear tags, that's been explained by Phil Valencia earlier on. Now, if we connect these two, then we would be able to run a clever algorithm that will be able to say, look, this is the data that I get from the cow, so we know where the cow is drinking, we know whether he's been treated reasonably, we know where he's been eating, etc. And on the other hand, we know what the actual digital rules would be, and we would be able to draw a conclusion whether we would be compliant to that or not. Now, for checking compliance, there's a whole variety of guidelines, and there's a number of ways where we can check that. So part of that we would check on the actual ear tag itself, so they will be checked locally on the cow, so the elementary checks whether the cow is being happy, yes or no, they'll be checked there. And there will be a more broader check that requires a composite or an aggregate, so it requires to reason over multiple cows at the same time, and it requires to, for example, take weather data into account, take data provided by the farmer into account. So that will be done on the cloud. We call it compliance checking on the cloud. So I'd like to switch now to Regis online to explain a bit more about the embedded compliance checking bit here. So Regis, the floor is yours. Regis, are you online?
I can see Regis is online.
Is he on mute?
But no, I can't see a mic. So he may be having trouble.
Right, so in the meantime, I'll just cover this bit of the presentation then. So the reason why we would have different levels of compliance checking is that if you want to take the overarching view of compliance and you would like to check it on the cloud, that means that you need to have data being transmitted from the cow to a separate server. That's not always something that is feasible. So there are a lot of we have a wireless communication network that's unreliable, or we don't have enough bandwidth, or in other cases, we just want privacy to be retained for particular cow behavior. So you need to keep that on the cow and not broadcast that to anywhere else. So as a result, we have developed a part which is called embedded compliance checking, so where we check a set of rules on the actual embedded devices. And whenever necessary, or whenever there's availability, we're able to actually send that data to the cloud and process that there further. So there's a seamless integration between the two technologies. So at the same time, embedded devices may have fairly limited computational resources. So there's only so much you can actually calculate on the device. So what we've done is we implemented an embedded virtual machine where rules are digitized into small code snippets. So these rules can be updated remotely, and there's a few elementary rules that we can execute then on the device, on the cow itself. Now, as I mentioned earlier, there's a lot of rules that go well beyond elementary behavior that we need to check. So we need to take into account, for example, whether it has been hot in the past couple of days. If the weather has been hot, then that means that the cow needs to be drinking a lot more. If we had a lot of rain, that means that, as I understood, that there's a lot of water already in the grass, so the actual necessity to drink all the time is a lot lower. There's other information about individual animals, whether they are special need animals, etc. So all the data combined and reasoning over cattle as a whole, that requires a more aggregate and composite view of the information that we get. So as a result, we need to take that data whenever available from the cows and from the weather stations and from the farm, take that into the cloud, compare that to the digitized welfare guidelines and standards we obtained earlier, and then we were able to reason over that. So in that way, we were able to identify potential compliance issues. We were able to identify potential problems like cows have not been participating with the rest of the herd, cows have not been drinking enough, cows did not get enough resting time during transport, all those kind of things, and we would be able to communicate that back to the farmer. So the farmer will be able to have, either on his laptop or on an iPad, he would get actual live reporting on how his cattle is doing, and is able to basically act on any kind of issues that might emerge. Now, the key outcomes here is that this technology is, although I presented it predominantly around the welfare guidelines, it is generic and broadly applicable. So this would work for any kind of rules. So we just did it this way because this will be a very nice application area in this context. But this will be working for different stages in the process, and this would work for a whole variety of laws and regulations. It also allows for remote monitoring. So in this way, it's not only that we can continuously monitor how the animal is doing, we also be able to provide an objective measurement as on how the animal is doing. It's not like, well, I think he's doing fine, and anybody that listens to me just has to believe me. We actually have objective data proving that the animal is actually fine, that it's been drinking more than enough, has been eating more than enough, and basically has been treated carefully when moved from one paddock to the next, all those kind of things. So on top of that, we would be able to do automated certification and compliance checking. So in the end, we combine all that data and we'll be able to say, look, if we give this stamp of approval, like you've been certified, we have proven that the animal is doing fine, you can actually trust that particular stamp of approval because we have the objective data lying behind that. And as a final point, in the end, we would be able to report on the actual animal behavior, and we would be able to go into welfare benchmarking. So we already have pretty high standards here in Australia. We would be able to prove that we are consistently above that benchmark, and we'd be able to even improve that image that we already have as Australians, that we are treating our animals well, very, very well. And we'd be able to show that we are consistently above that benchmarking level. So given this technology being more broadly applicable than just this particular prototyping case where we've been using this, what we're really looking for is well, industry partners that so look, these are other areas where we would really like to apply this technology. This technology is, even though it's just a demonstrator, it is ready to go. So we have really tested this out in the field, and it did work. So it would be really nice to actually take this on a broader scale and show how this works across the entire supply chain. So we'll be definitely looking for people that like to work with us here, and yeah, we'll basically show what we can mean for the entire Australian agri-food sector. So that concludes this presentation. If there would be any questions, I'm more than happy to take any of those.
Thanks, Nick. Thanks, Nick. And just on time, so I did not have to ring my bell. There is a question here for you. Have you considered the challenge that different state jurisdictions have different standards and these need to be harmonised? That's a big question.
That is indeed a big question. It's a very important question too, so thanks for that. So yes, we are able to, first of all, model individual state jurisdictions, so to take those rules in isolation. So you will be able to be compliant against individual rules, but you would also be able to compare those and identify those particular areas where they hypothetically will be contradicting and what would particularly be the cause of that contradiction. So you would be able to monitor whether a cow would, for example, be compliant in Queensland and where he would, for example, not be compliant in New South Wales, hypothetically. But you would also be able to combine those together and say, look, this cow has been compliant in both states. So basically take everything on one pile and check it against that. So the short answer would be yes.
Yeah, I can also add, could you hear me this time?
Yes.
Yes, Regis, go on. Yes.
Okay, yeah, the harmonization of the rules in general is not really not our job. It is a bit out of scope, but we can have various rules from the various jurisdictions, for sure.
Great. Since we've got a little bit more time, Nick, do you want to go a little bit more into the difference between the welfare guidelines on the device versus those that are supported in the cloud?
Yeah, sure. So in general, the reason why we had that distinction is that there's a lot of individual bits and pieces in terms of behavior that really relate to individual cow behavior. So, for example, if again, the example that I use a lot of times is the cow drinking behavior, because that is, pretty sensitive, particularly in the hot weather that we may occasionally have here in Australia. For every single cow, that is really important. So if there's only one cow that is deviant from that particular rule, that is a problem. So it's not like that we need to have a generic overview like, well, in general, the herd is doing fine. So here you really want to measure the individual cows and report on that. So in that case, you would definitely model that on the ear tag itself. So you have a reliable and immediate way of identifying any violation in that end. On the other hand, you may have more aggregate and composite kind of rules that basically reason over cattle as a whole. Like cattle as a whole need to be handled reasonably. So in that sense, you need to aggregate different behaviors of the cows together and see that in general they are relaxed, moving at a steady pace, and so on. So if there's one or two outliers that might be moving a bit quicker or a bit slower, then that is fine. But as a whole, at least you can reason over that and say, cattle as a whole has been handled reasonably. So in that case, we definitely do that on the cloud. Particularly if you want to include other information like the weather stations I talked about before. In those kind of cases, you definitely do need information from elsewhere. So you need to get information from your cows, you need information from weather stations and any kind of other information source that you may need, then combine that and then come to a conclusion. So that would definitely be a cloud thing. I hope that answers the question a bit.
Yeah, thanks, Nick. I will read out a comment from Sonia, which says, I really like the approach to auto-populate to make the process easier. I see the benefit, though, in empowering the producer to demonstrate top-notch welfare, which happens to coincide with complying with regulations. So just a comment, not a question. I guess we've got a couple of minutes left. So Nick or Regis, did you want to cover anything else? We don't have any other questions posted. Hold on. Yes, there is. There is another question. Okay. Do you think the results of this continuous monitoring could be aggregated into a single lifetime welfare metric?
In the end, yes. I think this is something that would also, I think it would be a separate area of research that we need to talk to with the experts from the Department of Agriculture and Food. I mean, I'm from Data61. I'm a computer scientist by trade, and I'm learning a lot about animal behavior in all the conversations that I had with the actual experts on it, particularly when talking about welfare guidelines, how to really measure that, how to quantify all that. So to have an overarching report in the end that is reliable, that is definitely something that I personally would be very interested in. I also think that is very, very useful. And the level of detail at which that we collect the data at this point would definitely be more than suitable to actually do that. So I think the bigger question would be, so how do we actually aggregate that? So what does that mean if, for example, a cow had one day where he was technically not drinking enough? So he should be drinking twice, but he only had one drinking event, let's say that. So if that happens over its entire lifespan of 3 years, what does that mean? So that kind of research would be important from that perspective. But other than that, I do think that we definitely have the basis here in terms of technology to completely support that.
Great, thank you. Another minute or so to go, so I can't see any other questions. Regis, did you want to add anything?
No.
No? Okay, I just wanted to give you the opportunity since we missed you earlier.
No, that's fine. I think Nick covered the slides correctly.
Okay. Well, I think I'll thank Nick and Regis. Thank you very much. Thank you to those who posted questions and comments.